All right, guys. So, welcome. This is chapter number 4. Robert here, and we're going to be studying network addressing tonight. Perfect. Let's get started. Okay, these are the sessions that we're going to be discussing tonight. We're going to talk about the IPv4 addresses and subnet masks. We're going to explain the features of an IPv4 address. We're going to talk about the types of IPv4 addresses. We're going to talk about how IPv4 addresses are obtained and how they are managed, as well as its evolution, which is the IPv6 address scheme. Let's get started with the IP addresses. We already mentioned that. We talked about this last week. Just a recap, IP address is also known as the logical address. The IP address is usually associated with the network layer, so it lives in layer 3. So this is just a recap of what we talked about last week. So one more time, IPv4, a logical network address. It identifies hosts. So it identifies hosts in a network. It can be configured in contrast to the MAC address. So we mentioned this last week, but just to recap one more time, the MAC address is also known as the physical address. It's associated with the data link layer, and it lives in layer number 2 of the OSI model. So the IPv4 or the IP address is associated with a network interface card as well. Okay, but in contrast to the MAC address, it's not a burned in address. So it doesn't come from the manufacturer. You can change it. Okay, and how does the IPv4 address looks like? So we got two types of IP addresses nowadays. We have the IPv4 address and we got the IPv6 address. So the IPv4 address is one of the first iterations of the IP address scheme. So the IPv4 is a 32 binary bit address. For ease of use, these 32 bits, they are usually grouped in 8 bits each group, and it just basically looks like something like this: 192, 168, 1, and 5. So each one of the parts between the dots is a part of the IPv4 address. Each one of these between the dots is represented by 8 bits. Correct? These 8 bits in binary form, they can be translated to a decimal form. So with 8 bits, you can write up to 255 addresses starting from 0. Okay? This is just a binary to decimal. There is an easy way that you can convert from binary to decimal. You can use a binary to decimal calculator, or you can just do it by hand. Okay? Next week, we're going to study how to do some of the calculations to determine an IP address, a network address, and so on and so forth. For now, you just need to understand that an IPv4 address can either be represented by a binary form, so it would look like something like ones and zeros, or it can also be represented into its decimal form, and it would be a number between 0 and 255. And why 255? Because I just said that it's the highest number you can write with 8 bits. All right. Networks and hosts. So this IPv4 address, it actually tells us two types of information about a certain network. Okay? It identifies the network and it identifies the hosts. If you guys can see here, how many networks we have here in this example. Let's see if you guys are doing well. So we got one network here on the left. we got another network here on the right. So we got two LANs here, correct? The first LAN is the 192.168.18. This is one LAN. And the 192.168.5 is another LAN that we have in here, correct? If you noticed on the left, there is a portion of the IPv4 address that is shared amongst all of the devices in the left LAN. And it is in blue. So the portion that is shared between all of these devices is the network, correct? So all of these devices, they share this blue portion of the IPv4 address, and this blue portion of the IPv4 address is the network. So the 192.168.18 is the network of the left LAN, correct? On the right, you have the exact same thing. You have a portion of the IPv4 address that represents the second LAN. What address is representing the second LAN? 192.168.5. So it's the portion of the IPv4 address that is shared amongst all the devices within that LAN. Is that clear to everyone? Now let's have a look at the red portion of each one of the IPv4 addresses represented here. And we can just realize that the red portion is different for each one of the devices within that specific LAN. On the left, we have 192.168.18.99. This address is associated with the router. On contrast, each one of the endpoints, each one of the computers on the left LAN, they are represented by an IPv4 address, and the red portion represents the hosts, correct? As you guys can see here, the network address portion, it repeats itself amongst all the devices within that network. On contrast, the host portion, which is represented by the red color on the address, it's not shared between devices in the same LAN. Okay, so within the same LAN, the IPv4 address needs to be unique. You cannot have the same IP addresses for devices within the same network. Okay, that will cause conflicts and you won't be able to communicate properly within the network. Is that all good? On the right hand side LAN, we got .11 representing this device here, this computer, .22 representing this device, and .33 representing this device here. Okay, as you guys can see, each one of the LANs, they have a specific address. Okay, at this point we don't know exactly how a router works and we don't know how to configure a router, but from last week, let's do a recap. The routers are here because they are connecting different networks. All good? Let's move on.
Yes, thank you.
Now, how do we find out that a certain device is in the same network? Of course, one way of doing that is determining that they are physically connected. Like we have seen here on the network on the left, these devices are all physically connected to this switch here, correct? So physically, they are in the same network, correct? But in order for them to communicate, we need to make sure they share the same network in regards to their IP address as well. So this is a requirement. They need to be connected physically, but they also need to be connected logically. And by logically, I mean that the host, no, the network portion of the IPv4 address needs to be the same. So if I move this computer from this LAN into this LAN without changing the IP address, this computer will carry the same address and it won't be able to communicate with the other devices, even if I connect the cable physically. And that is because the IPv4 network address needs to be shared. So if I want to move this computer from the right LAN to the left LAN, I also need to change the IPv4 address. So I would need to change the network portion, which is this green portion, to the same one as the blue portion. And I could not keep the 0 because the 0 is used here as well. In this case, I could not use the 11 because the 11 is used here. All good? Now this .0 always represents the network itself. This is really important to notice as well. As we've seen, all these devices, they share the first portion, and every time that we put a 0 after the network portion, it's called the network IPv4 address. All good? Do you have any questions so far?
Can you just explain that again about the 0? Sorry.
Okay, so it's just that what is shared between each one of these devices here in this LAN? What is common between them? The first 3 portions of the IPv4 address. So the 192.168 and 18 is common to everybody in the same LAN, correct?
Yes.
So every time we put a 0 in the bits that are not the same for every one of them, we call this a network address because it represents the network. It doesn't represent a device specifically, it represents the entire network. Is that clear?
Thank you.
Okay. Okay, guys, and how do we represent these network address? How can we determine the network address? How can we determine a network? How can we get to conclusions to what are the bits that determine a network and what are the bits that determine hosts? How can we actually distinguish between these? And we have something called the subnet mask, and the subnet mask is just basically the bits that will determine what portion of the address belongs to the hosts and what portion of the address belongs to the network itself. Okay, and this is really important. The subnet mask is written with the same number of bits that we write an IPv4 address. So the subnet mask contains 32 bits as well. So the subnet mask also contains 4 parts that can be shared 8 bits each. Okay, so just like the IPv4, we could write the IPv4 address, which was 32 bits address. We could split it up in 4 parts, 8 bits each part. The subnet mask is exactly the same thing. Okay, now the subnet mask can be written with 8 bits, and it would be represented by 255.0.0.0. Once again, the maximum number that we can write with 8 bits is 255. Okay, so every time you see a subnet mask which is 255, it means all of these bits are set to 1. Okay, now we can write a subnet mask with 16 bits, and that would be 255, which is the maximum number you can write with 8 bits. 255 one more time because you need 16 bits. And you can also write the subnet mask as 255.255.255.0, and that would be 24 bits. We can calculate the number of hosts that a subnet mask allows us to have. Okay, so if I have an address, for example, 192.168.1, so I'm just going to give an example for you guys. Just going to get a notepad. Okay, let's say I have an IP address and this IPv4 address. Okay, let's get an example of IPv4 address, 192.168.1.0. So this IP address is a network address, and that is because it ends with a 0, as you guys can see. This address is a private address, so it can be assigned to any device within a LAN. So inside a LAN, you can assign this IP address to a device, okay? But remember, this is the network address because it ends with 0. This IPv4 address has a subnet mask associated with it. And the subnet mask that is associated with this IP address is the /24 or 255.255.255.0. So let's recap what we did in the Cisco Packet Tracer lab, because that's important for you guys to start to understand this a little bit better. When we did the Cisco Packet Tracer lab, we didn't worry about the subnet mask because I told you guys if you hit the tab button on your keyboard, that would be automatically filled by Cisco Packet Tracer. Okay? And that is because this address belongs to a specific class of address that we're going to be discussing later on. But because this address is in a specific type of address, it has a specific subnet mask. And this subnet mask is the 255.255.255.0. This 255.255.255.0, as we just seen in the presentation, it's got 8 bits, 8 bits, and 8 bits, correct? So it's 24 bits, right? So these 24 bits, they are all set to 1. That's why you have 255.255.255.0. Okay? What does the subnet mask actually tells me? This subnet mask is telling me what portion of the IPv4 address belongs to the network and what portion of the IPv4 address belongs to the host. Okay, just gonna write it down here. Correct? Is that clear to everyone? Can you guys all see this? Yeah?
Yes, thank you.
I think I'm gonna give it a little bit more zoom. Okay, it should be fine now. All right, so the subnet mask tells us what bits represent the network and what bits represent the hosts. Okay, so one observation here is the bits that are set to 1, they belong to the network. And the bits that are set to 0, they belong to the hosts. They will be used to represent the hosts themselves. All good? Now, what do I need to do to determine this? What do I need to do to determine what portion of my IPv4 address I can change and I can assign to the hosts within my LAN? In order to do that, I need to compare the IPv4 address with the subnet mask. I need to do a mathematical operation to determine this, okay? To determine what bits I'm going to be able to use for the hosts and what bits I'm going to be able to use for the network. In order to do that, I just need to get my IPv4 address, put it in here. Okay, and I will put my subnet mask right underneath my IPv4 address. Okay? And what I need to do is, every time I have the 255, it means all the bits in that portion. So every time I have the 255, I can conclude. We're going to see the detailed calculation later on. But every time I see 255, it tells me that the corresponding portion belongs to the network. Okay? So the part that belongs to my network is the 192. And I can just keep the 192 for me. I can use that for a host. The other portion is also a 255. All bits are set to 1. I can assign these to a device as well. So 168. Another 255, it determines that I can get this as well and put it into my address. So 1. The last one is a 0. A 0 means that none of the bits associated here, they are reserved to the network. It can be used to a certain host. So these .0 here, I can use. I can pretty much change these to any value that I want. But I need to notice that all of these need to be kept. I cannot change to make a new host within the same network. I need to keep it to identify the network. So the last one, I can change it because my subnet mask is telling me it's not relevant. So every time I have a 0 in my subnet mask, it's telling me it's not relevant for the network. I can change it. And we already saw that with 8 bits. So in this portion of the address, I have 8 bits. So we can write up to 255 with 8 bits. Okay? So I can pretty much use any address between 0 to 255. So any address between 192.168.1.0 up to 192.168.1.255 are the available addresses. Okay? Now we have some observations to make. When we have host bit set to 0, we are representing the network. We represent the network. And when we have host bits set to 1, we are representing broadcast, something called the broadcast address. Okay? So these two, by convention, they cannot be used for a host. The .0 is used to identify the network itself, and the .1, the .255, in case all the bits set to 1, is used to represent a broadcast address. So for example, when I say 192.168.1.0, this is a network address. It represents the network, correct? So this is the network address. And every time I have 192.168, in this case, of course, the 255, I'm actually talking about the broadcast address. As you guys noticed, everything in between these two addresses, that would be .1, .2, .3, .4, .5, .6, everything between 0 and 255, I can assign to a certain host in the LAN. Correct? Everything. So these two addresses, they are excluded addresses. They need to be excluded. So for example, in our Cisco packet tracer, we had two computers, correct? And I told you guys, these computers, they need to be in the same network, and I gave you the address 192.168.1.0. So when I'm giving you this address 192.168.1.0, and I tell you the subnet mask is 255.255.255.0, I'm actually telling you with the subnet mask the first three portions of the address you cannot change in the same network. They need to be the same for all devices. But the last portion, because the subnet mask is only 255.255.255 and the last one is 0, I'm telling you, the last portion can be whatever you want, but it cannot be 0 because 0 is reserved for the network itself, and it cannot be 255 because the 255 are all the bits set to 1, and this address is reserved for broadcast messages, and broadcast messages are those messages that are sent to everybody in the network. Okay, so in our Cisco packet tracer example, if I told you that we have to use the 192.168.1.0 network and the subnet mask was 255.255.255.0, you immediately know that you can use any address between the 192.168.1.0 until the 255, but you cannot use the 0 and you cannot use the 255 for the hosts. Okay? Because these two addresses, they are reserved. All right? So the subnet mask tells us the bits that I can use for a certain address. Is that all clear to everyone? All right. It's a little bit hard, guys, I know, especially because there's a little bit of math involved. Okay, so if you open up, now we need to discuss a little bit about the binary and decimal form. So I tried to explain to you guys how the subnet mask represents the network and how the subnet mask represents the hosts. But I try to do this in decimal format, but we need to go to the binary format to actually understand it a little bit better. Okay, so if it's still not clear to you, don't worry. Let's do this a little bit slowly. Okay, so I'm just gonna open up my calculator. You guys can do the same. Your Windows calculator. You can just change the format of the Windows calculator. And if we get the programmer calculator, we can actually do the conversion between binary and decimal. Now, just one question. This needs to be extremely clear to all of you guys. The decimal format is the format that we are used to understand. Okay? So when I tell you, I've got 28 years old, and you think, 28, I understand this number. I can understand the number 28. And that is because this is a decimal format. And we, as humans, we understand decimal format. The computers, they don't understand the decimal format. They understand the binary format. But sometimes I type the decimal format in the computer, but the computer translates this into binary. Okay, and that's why we need to understand binary as well. This will allow us to actually understand everything that's going on here. So you can do the maths using a Windows calculator to calculate a binary to decimal conversion, and it's extremely easy. You just need to type the value. So let's do a little bit of practice here before we move on. Okay? Just gonna separate all of this. Convert. So let's convert these address, the 192.168.1.0, into binary format. Okay? So let's do it together, guys. Open up your calculator, change it to programming mode, and let's do the conversion for 192.168.1.0. Let's see how it looks like in binary format. Okay, I'm just going to put it right beneath. So I'm just going to type the address, 192. So you type it in portions, okay? You need to separate the address. So I'm going to type 192 here. And as you guys can see, the bin is the binary format of these address. Okay? This is how it looks like in binary. Okay? So the 192 looks like 11000000. Okay? So I just done the conversion of the number 192. So you need to convert each one of the parts, guys, in the IPv4 address. So I just converted the 192. Let's do the conversion of the 168 address. One more time. Just going to clear up things here on the calculator. I'm going to type 168 now. And it shows up here that the binary conversion is 10101000. Correct? 10101110. All good? Let's do the 1. Clear things up here. Type 1. It shows me that it's 00000001. So it shows here only 4 bits. So every time you get less bits, because we actually need to put here 8 bits, because it's mandatory that each portion has 8 bits, I just need to fill up the bits that are not here inside. So my address is 0. So 1 can be translated to 0001 according to my calculator. But this portion of the address needs to have 8 bits. So I need to fill it in the rest of the bits with zeros. Okay? Until I get 8 bits. So I already have 1, 2, 3, 4. I need 4 more. So 1, 2, 3, 4. And then you get it done. Okay? Now I just converted 1 into binary format with 8 bits. If you do 0, you're just going to get a 0. So the binary conversion of 0 is 0. But I need to represent this 0 with 8 bits. So I'm just gonna, I need to add more zeros to the left. So I'm just gonna put 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now I got my IPv4 address in binary format. As you guys can see here, it's now in binary format. So the computer actually understands this. Okay? So let's
Rob, can I just ask a quick question, please?
yes.
So where the the network address represented one.
Sorry, I didn't get it.
So if you ever have a number like that, all the zeros go in front of the binary number it gives you. So with the network address of number 1, can you hear me?
Yeah.
Yep. So
Okay.
with the network address number 1 and you put it in the calculator
Mm-hmm.
and it came up 0001,
Yes.
when you've got to put those other zeros in, it's always got to go before that number, does it?
Yes,
Not
always.
after.
Always going to be before,
Okay.
because if you put it after, you change the number.
Okay, thank you.
Okay?
Yep.
If you put before, you don't change the number because it's all zeros. But if you put after, you change the number. It's similar to what we have in decimal. So let's say you have 10. If you add a 0 in front, you get 100. Correct? But if you have 10 and you add a 0 before, it's 0, 10. It's still 10. Do you get that? Is that clear? So
Yes.
even in decimal, if you put a 0 after, you change the number entirely. But if you put a 0 before, you're not changing the number. It's just something extra, right? But the number is not changed. Okay.
Makes sense.
Let's do the subnet mask, guys. Got the subnet mask here. And let's type the subnet mask in. 255.25, oops, 255.255.0, correct? Can you guys do this for me? For those of you guys that have the calculator in programming mode, can you tell me the decimal to binary conversion of this number, please? Oh, someone got it. Everything's set to number 1. Okay? So if you type the 255 in here, okay? You remember, guys, I told you that the maximum number that you can write with 8 bits is 255? There you go. Everything set to 1. Remember, it's 8 bits set to 1, guys. So to represent 255, you need 8 bits. So I'm just going to, let's write this down here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the last one is 0. So you set all the bits to 0. 1, 2, 3, 4, 5, 6, 7, 8. Is that all good? Perfect. So what do you do now? The subnet mask, all the ones in the subnet mask indicates the bits that belong to the network. All the bits set to 0 in the subnet mask represent the hosts, represent the addresses that you can assign to each one of the hosts within your network. And I hope this is clear to you guys, because everything that you do in networking, everything, it will involve IP addresses, and it will involve in determining what's the network address, what's the host address, and where do they fit into your design, into your network. All good? Perfect. So what do we usually do to determine something? Okay? We put one above the other. So I will put the IPv4 address in binary form first. Just gonna copy and paste it. Okay? And I put the subnet mask below the IPv4 address. Okay? Oh, no, that's not the one. Oh, good. So I put one on top, the other one below. So what we do is we do a math operation, which is the, which operation we do here? Does anyone know which operation we do here to determine the number of bits? We do an ANDing operation. So we're just basically doing an AND operation in here. But this, you don't have to worry about worrying, it's ending, it's not ending. The only thing you need to know is, if you have two ones, that means you keep the value. If you have 1 and a 0, the 0 will take precedence. Okay? So it's like a multiplication. Someone said that it looks like a multiplication. Okay? So let's see if we can get to the result of this. Just gonna put an equal sign here. So once we do the ending, so we do something called the ending. So that basically means 1 times 1, 1. 1 times 1, 1. 1 times 0, 0. 1 times 0, 0. 0, 0, 0, 0. Okay? And then dot. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. 1 times 0, 1. Oops. 0. 1 times 1, 1. 1 times 0, 0. 1 times 1. Okay? And then you keep going all the way Okay? It is easier. The easiest way for you to think about this is it's only gonna be 1 if you get 2 ones. Everything else is a 0. So if you keep this in mind, it's gonna be much easier. Every time you have ones, you keep the 1. Every time you have a 0, it's a 0. Okay? And now what we do here, after we do this operation, we convert this number back to its original value so that we can actually see the number. So let's convert this number back. If you convert this number back, what do you get, guys?
One nine two dot 168.1.0.
Yeah. So if you put in a calculator, you get this. 168.1.0. Correct? So this is the network address. Okay? Is that all clear to everyone? Okay, I'm gonna give you guys an example now that you guys need to help me find. I will give you the host address. Okay? The host address is this. And I will give you the subnet mask. And the subnet mask is this. I need you guys to give me the network address. So how would you do this? Anyone?
So you put the 10 in your programmer calculator and it comes up 1010, but because you've got to have 8 bits, it'll be 4 zeros, 1010.
Okay, let's do this together. So I'll put the 10, and the 10 gives me 0010, but I need 4 more bits because each one of the portions need to have 8 bits. So I need to add 4 more bits in front of it. Okay, so I'm just converting my host address to binary form. How about the 1? What's the binary conversion, guys? It's 1. So you just need to add the zeros necessary to have a 8-bit address. So 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. The 8th bit needs to be 1. And then you have exactly the same. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And what's the binary conversion, guys, of the subnet mask 255.000? Anyone? Quickly,
It's,
guys.
it's 8 ones, 8 zeros, 8 zeros, 8 zeros.
Okay. Guys, if you get lost at some point, don't worry. You can watch the recording later on. But just bear with me for a second. We're just about to finish this. Okay, now what do we do here? We do an ending operation. So basically, what value we're going to get here. So I already told you this. You don't have to worry about doing one by one. Just be aware that you only get 1 where you have 2 ones. So everything else is 0. So if you do it this way, it's going to be much easier for you. So I see that there's a 0 on the first 6 bits. So I immediately know it's 0. So I got 2 ones, 0, 0. All good. And now if I convert this back, what do I get? Guys?
10.0.0.0.
This is what?
The network address.
Perfect. Is that clear to everyone? Awesome.
Yes, thank you.
Perfect. Let's move on. I hope this is clear to you guys. In the end, we can do a little bit more exercises so we make sure we can understand all of this. Oh, yeah, this is actually a mistake. Sorry, guys, we need to get back here. Yeah, the binary of 10 is not only 10. There's another 10. Ah, thanks very much. Someone noticed that. Okay, so it's actually 10, 10, guys. It's not just 110. So it's going to change here and here. Okay? In the end, the result is the same because we thought that was a 10 anyways. So this is actually a 10. The 10, 10 is a 10. All good? So someone helped us out. Thank you so much for noticing. No one have noticed this before. Is that all good now, guys? Is that clear? But it doesn't change anything we did. It's still all good. Perfect. All right. Thank you so much for noticing, guys. It's great. Someone noticed that. Okay. Let's do another example just to be sure that you guys are all familiar with this. I'm going to give you another address, and you guys are going to help me out. So the host address will be equal to 172.31.0.1. Okay? This is the host address, guys. And we just basically need to figure out the network address. I'm going to give you the subnet mask. Okay? So the subnet mask for this address is 255.255.0.0. Okay? And we need to do this one. We need to find out the network address. Okay? So what do we do here, guys? Let's write it down to binary. It's going to make our lives easier. Or if you already got the scheme that I told you guys, this is a 255. The 255 maintains the first portion. The 255 on the second portion maintains the address as well. And the zeros will just basically make the other portions 0. If you still cannot do that, you can do the binary calculation. It's going to help you get to a conclusion. So basically, let's find out the 172 first so that we can write it down. So 172. What's going on with my calculator? I changed to bit. Okay, so someone actually send the message. Okay. Let's get going. 172 will be 10, 10, 11, 0, 0. What else? The 31, how do you write 31 in binary? 31, 0, 0, 0, 1, 1, 1, 1, 1. Okay. And then you got the 0, which is all zeros. And you got 1, 4, 5, 6, 7. And then you got the subnet mask. We're going to do an ending again to figure it out. And the 255 is just all ones. Okay. So what do we do next? We do the ending. As I told you guys, a tip. Just every time you have a 1, 1, you keep a 1. Every time you have 1, 0 is a 0. So 1 here, bam. Then you got 0, 0, 0, 1, 1, 1, 1, 1. And what happens after you convert this back? You got this. Okay, so this is the network address. Okay, remember one thing, guys, that I told you. You can have any address that you want as long as you respect the subnet mask. So this subnet mask is telling me the first portion, okay? This portion is reserved for the network. As we noticed, the network is 10.0.0.0. Every other address can be a host address except the 0 and the 255, all set to 1. So if you take the network address, which is this one, we already seen this. Okay, so let's find the broadcast address. The broadcast address is when you take all the host bits, okay, so all the zeros in the subnet mask, and you set them to 1. So if you set all of these bits to 1 in the subnet mask, after you calculate the network address, okay, so you actually take all of this, these 3 portions, all of this in here. If you set all of these bits to 1, you find something called the broadcast address. If I do it in this address, what do I get, guys? This is the broadcast address for this network. Okay, so we already found out the network address, and we already found out the broadcast address. Everything in between can be a host address. Okay, so it could be 10.0.0.1 is a host, 10.0.0.3 is a host, 10.1.1.1 is a host in this network, and so on and so forth. So everything in between this is a host. All good? We have the exact same here as well. For this 172.31 address, we can actually find out the broadcast address for this network. One more time, the broadcast address is the address that is used if you want to send a message to everyone in that network. What is the broadcast address in here, guys? Can someone help me? So what did I do here? I checked the subnet mask. The subnet mask is telling me that the first 2 portions are reserved for the network. The other 2 portions are for the hosts. And we already seen this. If I set all the host bits to 1, after I calculate the network address, I will get the broadcast address. I hope this is clear to everybody. Let's move on. Okay? Now we got to this formula here, the number of hosts. 2 to the power something minus 2. What is this telling me? This is telling me the number of devices that I can configure an IPv4 address. And it's 2 to the power of x. X is the number of bits that I will use for the hosts. And the minus 2 is because I cannot use the zeros, the all zeros, and I cannot use the all ones because the all zeros, they represent the network. They cannot be used for a host. And the all ones, they represent the broadcast address. They cannot be assigned for a host. Is that clear to everybody here? I hope that's clear. Let's do a little bit of calculations here in our example. Okay. The subnet mask is 255.0.0.0, correct? There is another way we usually represent the subnet mask, and this is the slash notation. So I put a slash, and I put the number of bits that are reserved for the network. In this case, it's 255. We translated the 255 to binary, and that's all ones. So I count the number of ones that I have in the subnet mask, and these will give me the slash notation. How many ones do I have here? Anyone wants to give it a shot? 8. My slash notation is /8. Okay? In this one, guys, what's the slash notation of this subnet mask? 255.255.0?
16.
16. So this is a /16 address. Now you guys know what the slash notation is, and you see this is extremely important because no one will ever tell you a subnet mask, it's 255.255.255. It's not practical. So what we usually do is we say in a slash notation because it makes our lives easier. I will give you a slash notation and you're gonna give me the decimal format. What is /24? Anyone? Exactly.
255.255.255. Yeah.
Exactly. 3 255s consecutively. I hope this is clear to you guys. You just count the numbers. Let's go back a little bit. This is a /24 notation, the 192.168.1.0. And that is because I have in my subnet mask 24 consecutive ones in here. It's a sequence of 24 number ones. So this 255.255.255.0 can also be represented by /24 notation. I hope this is clear, guys, to you. You will need to know this. You're required to know this in the IT industry. You need to know. This is a must know. Not only for the exam, not only for the project, but this is important for your careers in IT. You need to know this. Clear? All good. Let's keep going. So this 2 to the power of x, so this is basically 2 to the power of number of bits. This x is the number of bits I have for a host. Okay? We see that the IPv4 address, how many bits the IPv4 address has, guys? 32. The slash notation of a subnet mask, we see that that's the number of bits we have for the network. Okay? So the number of bits that we have for the hosts is 32 minus the subnet mask. So if in this subnet mask I have 24 bits for the network, how many bits left do I have for the hosts? 8.
8.
So it's everything that is left. So if out of the 32 bits I have in IPv4, I use 24 for my network, the other 8 is for hosts. Now, if my subnet mask is /8, how many bits do I have for the hosts? 24. If I have /16, how many bits I have for the hosts?
16.
16. Is that clear to everybody? So with this formula, I can calculate the number of addresses. Okay? This x is the number of bits reserved for the hosts. So let's do this exercise. Let's find out how many hosts we can have in each one of the networks. I will start with this one. How many host addresses we can have in here? So we need to do the calculation. 2 to the power of this x is the number of bits for the hosts. We notice that we have 24 bits for the network. So we are left with 8 bits that we can assign for the hosts. Okay? So these 8 bits. We need to do the calculations. 2 to the power of 8, 256 addresses. But you need to discount 2. And why do you need to discount 2? Because the all zeros represent the network and the all ones represent the broadcast. These cannot be assigned, and that's why you have -2. So someone help me do the maths. How many hosts?
254.
254.
And that is because 2 to the power of 8 is 256 minus 2, 254. How about this one? How many hosts we can have here, guys? Do the maths. I want you to tell me this one, and I want you to tell me this one. Anyone doing the maths? Is there anyone doing it?
I'm lost, sorry. So the top one is at 24 at the top, the hosts?
Oh yeah, the one on the top is /8.
Ah, right, sorry.
So you got 24 for hosts. So it's 2 to the power of 24 minus 2. Just gonna put scientific. So it's gonna be 2 to the power of 24 because we got 24 bits reserved for the hosts minus 2. We can write these many addresses. Okay? Has someone done the last one? So the last one is actually 16 bits for the hosts. So 2 to the power of what? Oops, sorry guys. 2 to the power of 16 minus 2. These are the many addresses. We can write it down with this. All good?
Okay.
Now you know how to do the calculations. You know what a subnet mask is. You know how to calculate a network address. You know how to determine a network address. You know how to determine a broadcast address. And you know how to calculate the number of hosts you can have given an IP address and given a subnet mask.
2 to the power.
And you guys need to know this. Okay, is that all good? Perfect, let's move on. The types of addresses, we identified the types of addresses, guys, and we have different classes of IP addresses, and these classes of IP addresses, they are different subnets. Okay, every time you have something /28 and this something is from 0 to 127, it's class A. Every time you have something from 128 to 191.255 and it's /16, this is called the class B address. Every time you have an address between the 192 to 223.255.250 and it's a /24, this is a class C address. Okay? We have also something called the classless addresses, and these are the IPv4 addresses allocated on any address boundary. Okay? Anything that doesn't necessarily is like class A, B, or C. As you guys can see here, this is just out of curiosity, the number of addresses that you can have in each one of the classes. Okay? So for class A, between this range, you can have up to 16,777,214. For class B, it's all of this, 65,534. And for class C, it's all of this, correct? And I don't know if you noticed, but I did this on purpose. We actually did this tonight. So when I asked you guys to do this, I've actually given you guys examples of addresses within each one of the classes. So I will ask you, this 192, which class it belongs to? Class C. Exactly. Very good. Okay. We did the calculations, guys. How many host addresses? 254. This is exactly what is given here. You can have up to 254. Now this address in here, which class is this based on the table here? Anyone knows this? This is a class B address. This is a class B address. Is this a class B address? No, it's a class
No, it
A.
does A.
No, it's a class A, guys. Yeah, it's /8 and start
Yeah.
with 10. So this is, I did this on purpose. I got in different orders to force you guys to identify. So we identified the class C, we identified the class B, the class A. Which class do you think the other address is, guys? The other address that we calculated. The 172?
Class B.
Exactly. It's a /16 address. All good? Perfect. Let's move on. And we did all the calculations correctly. We got the exact same numbers when we did this. Yeah? 65. And just make sure it's correct. 65,534. 16,772,14. Yes, we did all the calculations correctly tonight. Awesome. You guys did great. Let's move on. Private addresses. So this is a convention, guys. These addresses that are between these ranges, they are determined in these range. So every time you're talking about a private addresses, I already mentioned that the private addresses, they are assigned within a LAN, okay? And the network ranges for each one of them are according to the following. The 10.0000 is a private address, class A. The 172.16 is up to the 31 is a private address, class B. And the 192.168 up to the 192.168.255 is a private address, class C. Now, the addresses that I've given you guys tonight, are these addresses private or public?
Private.
They are all private addresses because they are all in here. So I've given you the 10, I've given you the 172.31, and I've given you the 192.168. All of these addresses, guys, because they are private addresses, you can use inside a LAN, you can use inside of a local area network to assign to each one of your devices. Okay? And now you know exactly why when you check the IP configuration on your device, you usually have an address in either one of these ranges. Okay? So your router, your multi-purpose device that you have at home, will give you an automatic IP address using DHCP, and this automatic IP address is going to be a private address, and it's usually going to be in either one of these classes. So I'm going to show you guys mine, and you're going to tell me which class of address is that. So I'm going to open command prompt. We learned these already. I'm going to open as admin. Yes. And then I'm going to do the command ipconfig /all. This is going to display all the IP configuration in my device. I hit enter. So these are all the IP addresses associated with my machine.
We're in class A.
So check it out. So I'm gonna get one of them. This one here.
Class A.
Which class is this address, guys?
Class
Class
A.
A. Okay, it's actually got a different subnet mask. Okay, so this is actually, this is not a class A address because these actually doesn't belong in here. Okay, because it says class A, the network is 000. Okay, so this is not a private address. Okay, let's get another one. Let's get another one here. This one, another one which is easier for you guys. 192.168.56.1. Which address is this?
Class C.
This is class C. It's 192.168, and it falls within this range of addresses. This is a private address. It's class C. Okay, as you can see, the subnet mask is 255.255.255.0. What is the slash notation of these address, guys? Anyone? Slash notation of the subnet mask? /24. Perfect. Any question? Everyone? All good? Okay. So every time you use a private address, you need to understand a few things about the private address. Okay? This private address is not an address that is used to the internet. Okay? It's only visible inside your network. Okay? But you might be asking, how can I access the internet if my IP address is a private address? That is a question, huh? So basically, before you go to the internet, your router or your multi-purpose device you have at home will translate this address to a public address. A public address is an address that is reachable to the internet. So the public address is the address used to reach the internet. Your router, your multi-purpose device, we talked about this already, actually has a public address when it connects to the outside world. So your router has a public address to connect to the outside world. And this translation from a public address to the private address so that you are able to reach the internet is network address translation. So it uses net. Okay, you'll see this later on, but I'm just telling you guys that the public address is not the address used to reach the internet. The private address is not the address used to reach the internet. The public address is the address used to reach the internet. Okay? Another thing that we need to be aware of is the loopback address. And by convention, the loopback address is 127.0.0.0 network. So any address pretty much with the 127 is called the loopback address. This loopback address is an address to test. It's a self-test address. So you're just basically testing your network interface card to make sure the IP protocols are running into your machine. So I'm just going to open my command prompt here, and I'll show you guys how it looks like. because I will ping the 127.0.0.1. So these address, every time you execute these tests, you are just basically testing connectivity to yourself. You're just basically testing all the layers of the OSI model to make sure everything is working properly. Okay? You can execute this test yourself and it should work. Okay? If you have internet connection, it must work, because that means all the protocols, all the layers are functioning properly. All right. All right, all right. Well, okay, yeah, we finished this. And now we need to discuss about the types of messages we have in the IP protocol. So every time you want to send a message to a specific person, you need to specify the host address of the machine. Okay? So the host address allows you to reach a specific device. When you want to send a message to everybody in the network, you need the broadcast address. When we studied the ARP protocol last week, the ARP protocol, just a recap for you guys, is a protocol that is used when you have the IP address and you need to find out someone's MAC address. Okay, this is the ARP protocol. And we notice something in the ARP protocol. Because we know the IP and we don't know the MAC, we need to send a message with the IP that we know and the broadcast MAC address, which is the OF's address. Okay? So the IP also has a broadcast address. We set all the host bits to 1. Now we also have a specific type of address in IPv4, and that's called the multicast address. The multicast address is when you want to send a message to a group of specific hosts. It's usually in the reserved range 224 up to 239. So every time you see a packet that is destined to 224 up to 239, that is destined to a group of hosts. Okay. So we already studied this and we already mentioned this. The IPv4 addresses, they can be assigned statically. And by statically, manually, they mean the same thing. Dynamically can also be associated with the word automatically assigned as well. Okay? The fact that you can assign an IP address automatically, you use the DHCP protocol, which is also known as the Dynamic Host Configuration Protocol. All right? So based on that, if you have a large organization, guys, with 500 PCs, which type of IP assignment you think is the most appropriate? Dynamic.
Dynamic, yeah.
Yeah, and that is because you have too many devices, so it's inconvenient for you to go on each one of the devices and configure an IP address. All right. Where do the DHCP addresses come from? This is a question we need to address. Usually a local dedicated PC-based server, so you can actually set up a server to assign IP addresses. In a home network, if you don't have a server, you can actually use the wireless router or the wireless device itself to assign the DHCP addresses. How does IPv4 DHCP work? This is just a brief explanation of how the DHCP process works. So a client that doesn't have an IP address will send a message to the broadcast address, which is the all 255s, okay? And the MAC address will be the all Fs. So the message will be sent out to everybody in the network, and everybody will receive this message, okay? We call this message a discover message. So it's a DHCP discover message. It's sent out to everybody in the network segment. Okay? Everybody will get the message, but only the DHCP server will respond back to the client, and it will offer an address that is available. Okay? The client will then respond to the server accepting that address, and we will start to use that address after that. The server will send a message back acknowledging that. After this DHCP process is finished, the client now has an IP address that was available, and the client is now able to communicate using the IPv4 address that has been assigned to him. Okay? Hope that's all clear to you guys. IPv4 address management. Each host on the networks uses a default gateway to reach other networks. When we did the Cisco packet tracer, okay, I don't know if all of you guys remember that, we didn't configure a default gateway address even though it was there. So we could configure it. But we didn't do that. And why? Does anyone know why we didn't configure default gateway in the Cisco packet tracer that we did?
Is it because we're only in a network and not use it going out into the internet?
Exactly. Because we were not going out of the network. We were staying in the same network. We didn't need a default gateway. We discussed the default gateway before. The default gateway is an agent that will allow us to have access to other networks or the internet itself. The default gateway is the router interface that connects to the LAN. Okay? This needs to be clear, guys. The default gateway is the router interface that connects to our local area network. All right. We already discussed this throughout the entire course, but I need to make sure all of you guys are aware of this. Okay? This is the basic fundamentals of any type of network. All the internal hosts, they must be assigned addresses within the same network. So we already mentioned they need to be physically connected and they need to be logically associated, and logically associated means they need to have the same network portion in the IP address. Correct? They also need to have the exact same subnet mask. And that is because it's a consequence. If they are in the same network, it means they have the same subnet mask. The default gateway and other network information need to be shared between them as well. The network assigned to the internet side of the integrated router is referred to as the external or outside network. So you have a router, you have a LAN on your right, and this router is also connected to the outside world as well. This router might be connected to the internet service provider that's got a DHCP server, and usually this interface of this router is assigned by the DHCP server of the internet service provider. This integrated router sometimes assigns the IP addresses to each one of the clients using DHCP or automatically assigning addresses to each one of the clients. The integrated router serves as the boundary between the local internal network and the external internet. This is exactly what you have at home, guys. Exactly. You have an integrated router, or multi-purpose device. It's got switch functionality, it's got router functionality, it's got wireless functionality, and so on and so forth. So this device that you have connects to your internet service provider and also is responsible to assign an IP address for each one of the devices within your home network. Okay, this translation between the private and public addresses, I mentioned that briefly to you guys, but in order for you to reach the global network or the internet, what you need to do is you need to translate between addresses. Okay, all the private addresses within your LAN, they need to be translated to global public addresses so that you are able to reach the internet. So this NAT process, it happens everywhere. And because these addresses in a private LAN, they are translated before they go to the internet, is the reason why you can repeat this address pretty much everywhere. Okay? My computer can have the IPv4 address 192.168.1.2, okay? And I have my home router, and this address is translated before it goes to the internet. And because of that, because of this translation, we can reuse the private addresses. So at your home, you can have the exact same IPv4 address in your host machine, but when it reaches the internet, it's translated to another address. So the public addresses, the addresses that are used to the outside world, they need to be unique, but the private addresses, they don't have to be unique in different networks. Inside the same network, they need to be unique, but outside, they don't need to be. All right. It's been hard, huh? So we talked about too many things so far, but I have some good news for you guys. We are about to finish, okay? So stay with me for maybe 5 to 10 more minutes, and we're going to be able to finish this. So let's talk about the evolution of IP addresses, the IPv6 addresses. So it's been a while that we've been using the internet, and there is a trend going on in the internet. We're just basically connecting more and more devices with time. So in the past, we had fewer devices connected to the internet, and as technology evolves, we are connecting more and more things to the internet. Nowadays, you can even connect a smart lamp to the internet. You can connect your smart watch to the internet. You can connect, even some cars can be connected to the internet nowadays. Okay? And this trend is growing so fast that at some point, someone has thought that the IPv4 addresses was going to run out. So at some point, someone said, mate, we are going to run out of addresses. And remember, the public addresses, they need to be unique. So someone came and said, man, in the future, we will run out of IPv4 addresses and we won't be able to connect anything to the internet anymore. Okay? So that's why IPv6 came. And IPv6 came to address the shortage of IPv4 addresses. Okay? So the benefits of IPv6, it allows us to have more IP addresses. There is no need for us to translate the addresses because IPv6 is so huge, guys. It gives us so many addresses that we don't need to differentiate between public and private addresses anymore. Because we have so many addresses, we can have an address for each one of the devices in the entire planet. IPv4 didn't allow us to do that, and that was why we had the need to have private and public addresses, because we could repeat the private addresses in multiple LANs. But IPv6, we don't need to do that because IPv6 is so massive. It gives us so many possibilities. It gives us so many addresses that we don't need to worry about that anymore. Okay? Before IPv6, NET and the fact that we had private and public addresses prolonged the life of IPv4. Otherwise, IPv4 addresses would have run out ages ago. Okay? Awesome. What are the differences between IPv4 and IPv6 addresses? Address auto configuration, link local addresses. We're going to discuss and explain each one of these later on. But for now, you just need to know that IPv4 allows us auto configuration on each one of the devices. The IPv6 addresses, they allow us to configure link local addresses as well to allow communication within the same network. So within a certain LAN, we don't actually need a global IPv6 address. We can use a link local address, and this will allow us to communicate between devices within the same LAN. IPv6 address formatting. This is where you need to pay attention because this will be asked for you and you need to know this. How does an IPv6 address looks like? And an IPv6 address is a 128 bits address. Okay? So IPv4 is 32 bits, IPv6 is 128. Okay? The main difference is because IPv6 is so massive, because IPv6 has so many bits available, IPv6 addresses are not represented in a binary format usually. It's usually represented in a hexadecimal format. Does anyone know what a hexadecimal format is? So we have binary format, we have hexadecimal format.
Is that numbers and letters from A to F and 0 to 9?
Exactly. Exactly. So it's basically 16 numbers and characters. And numbers we have 0 to 9, and characters we have A to F. And we have 16 of these numbers and characters. And for 16 of these, we can represent them in binary using 4 bits. Don't worry about this for now. We can do the calculations for IPv6 later on. For now, you just need to know that an IPv6 address is a 128 bits address. It's represented with letters and numbers. The numbers, they go from 0 to 9, and the letters, they go from A to F. Oh, good. That's all for tonight, guys. Before we finish, you usually get this question. Sometimes you get an IPv6 address. Sometimes you get a random number, a random combination of characters, and you are asked to determine if that is an IPv6 address or if it's not an IPv6 address. The easiest way is you check each one of the characters and you see if it's 0 to 9 or A to F. So for some of your chapter exams or for some of your chapter quizzes for this chapter, you usually get something like this. Okay? And you are actually asked to say if this is an IPv6 address or not. second, it's missing some things. So I ask you guys this question: is this an IPv6 address?
I would say yes, but no, because you've got a G in there, and I thought it was A to F.
So you can have characters from 0 to 9, and you can have characters from A to F. So all of these are fine, except for this G. There is no G in an IPv6 address, so this is not an IPv6 address. Okay? Awesome. So that's all for tonight, guys. That's all you need to know. You need to know how to differentiate an IPv6 address and a known IPv6 address. I hope that's clear to you guys. We did a lot of maths tonight, so I strongly suggest you to review this later on. Okay? Awesome.
Thank you, Robert. That was excellent.